Good morning, everyone. Myself, B. Niveditha. I'm working as an assistant professor in Marri Laxman Reddy Institute of Engineering and Technology. Today, I'm going to discuss about first order logic. So, introduction. First order logic is a formal system used in AI. AI is nothing but artificial intelligence. It represents facts, objects, and relationships, and also called predicate logic. Why we are using FOL in AI? FOL means first order logic. It represents knowledge clearly, used in expert systems, helps in reasoning and inference, more powerful than propositional logic. So, represents knowledge clearly means the statement is very structured manner, clear manner, and in expert systems also it is like humans understandable language, helps in reasoning and inferences, and more powerful than the propositional logic. In propositional logics and or like we used. Next, so what is FOL, first order logic? First order logic is another way of knowledge representation in artificial intelligence. It is an extension to proportional logic. So this is the another way of artificial knowledge intelligence knowledge representation. It is extension in to proportional logic. FOL is sufficiently expensive to represent the natural language statements in a concise way. So means natural language NLP. So it is a machine language to represent the understandable language. First order logic is also known as predicate logic or first order predicate logic. Next, first order logic is a powerful language which develops information about the objects in easy way. So in that first order logic, objects relations are there. So it is easy to develop the information about the object easy way. Next, FOL also express the relationship between the objects. So the relationships is maintained by objects. Next, FOL assumes the following things in the world. Objects. Objects is nothing but name, numbers, name, characters, variables like that. So examples A comma, B comma, people comma, numbers, colors, bars, theories, squares, bits, bumpers, etc. Relations. It can be unary relations such as red round is adjacent, or n-ary relation such as the sister of, brother of, has color, comes between. Functions, father of, best friend, third mind of, and of. So we have to choose the examples in one by one. Next, the syntax of FOL, first order logic, determines which collection of symbols is a logical expression in first order logic. The basic syntactic elements of first order logic are symbols. So constants 1 comma 2 comma a comma names John, Mumbai, cat, etc. Variables it represents x comma y comma abc and so on. Predicates brother, father, like that. Functions square, left leg off, right leg off, like that. Connectivities and or negation, like that. Equality, so we know the equality symbols. Quantifiers means for all there exist. This symbol represents the for all and this symbol represents the existence. Next, extensions and natural variation atomic sentences. Atomic sentences are the most basic sentences of first order logic. These sentences are formed from a predicate symbols followed by a parenthesis with a sequence of terms. We can represent the atomic sentences as predicate of term 1, term 2, and so on, term n. Example, Ravi and Ajay are brothers. So how we can you write brothers of Ravi comma Ajay, or apple and banana are fruits. So how we can you write fruits of apple comma banana. So we have to represent like that. So another example, Chicky is a cat. So cat of Chicky. Here cat is an object. Next, atomic sentences. So what is atomic sentence? Atomic sentence is equal to smallest meaningful statement. So like in previous slide, we show that Ravi and Ajay are brothers. So this is the smallest sentence. Here we need not to use is, or, and like that. Okay. So example, human of Socrates. Next, complex sentences. Complex sentences are made by combining atomic sentences using connectivities. So connectivities is nothing but and and or like that. Okay. First order logic statements can be divided into two parts. First one is the subject part and second one is the predicate part. So in subject part, subject is the main part of the statement. In any statement, subject is the main part of the statement. Predicate. A predicate can be defined as a relations. It shows the relations which binds two atoms, which binds two atoms together in a statement. So in any statement which represents the two atoms, in that atoms it then represents the relation. Next example, consider the statement x is an integer. It consists of two parts. The first part is x and is the subject of the statement, and the second part is it is an integer known as a predicate. So here x is the subject, and is an integer is the predicate form. Like that we have to write. Next, predicate symbols. So what are the predicate symbols? Predicate symbols represent properties of relations. In previous slide, we know the predicate symbols. So it represents the properties of relations. So examples, tall of x, student of x, greater of x. So here tall is an object, x is a relation. Next, quantifiers in first order logic. A quantifier is a language element which generates quantification. These are the symbols that permit to determine or identify the range and scope of the variable in the logical expressions. So quantifier is a language which eliminates the quantification. The symbols. So in quantifiers also here we have to use two types. While using the two symbols, we have to represent the sentence formation. So this is these are two types of quantifiers. So what is that? Universal quantifier and existence quantifier. In universal quantifier is nothing but for all, everyone, everything. So the symbol represents the invert of A. Existential quantifier for some, at least one, reverse of E symbol. Okay. Next, universal quantifier is a symbol of logical representation which represents that the statement within its range, it represents the statement within the range only is true for everything. That statement will be true when for everything or every instance of particular thing. Okay. Next, the universal quantifier is represented by a symbol reverse A or inverted A, which resembles an inverted A. Example, for all x, human of x. So we have to, in anything we have to write for all x, student of x, like that you have to write anything. Okay. Next, connectivity is how the connectivity is logical connectivity is and or not implies. These are the connectivities. Next, if x is in a variable, then for all x is read as, how to read the statements? For all x, for each x, for every x. Next example, all men drink coffee. So the statement is all the men drink coffee. So let variable x, which refers to a man. So all x can be represented in UOD. UOD means universe of discourse, as below. So x1 drinks coffee and x2 drink coffee and x3 drink coffee and so on. Xn drink coffee. So in short notation we can write as for all men of x drink x comma coffee. Okay. So how to represent this in diagram representation? X1, x2, x3, x4, x5, x and so on men. So x represents the man. That's why we have to write for all man of X. First drink, ever drink. So who's the drink? Man's man comma. So which they drink coffee. So drink of X comma coffee tends to for whom, for all men's, for men of X. We have to write like this in universal quantifiers. It will be read as a there are all X where X is a man who drink coffee. Next one, existential quantifier. Existential quantifiers are the type of quantifiers which express that the statement within its scope. So we express the statement within its scope is true. Within the scope is true, then only for at least one or instance of something. So within its scope is true for at least one instance of something. That type of condition is known as the existential quantifier. It is denoted by the logical operator reverse of V, or this is the there exists symbol. Example, there exists student of X. How to write? There exists student of X. Next, if X is a variable, then existential quantifier will be there exist of X, or there exist X, or there exist of X. So we have to write like this or like this. Both are same, and it is will be read as a there exists A for some X for at least one X. In universal quantifier, we have to represent for all. In there existent quantifier, we have to represent there exist. Example, some boys are intelligent. For example, in class, the students are in total students are 60 members, but all the 60 members are not intelligent. Only some for 1 to 5 or 1 to 6 members only intelligent. So that type of condition is applicable for the existential quantifiers. For example, some boys are intelligent. X1 is intelligent, X and or X2 is intelligent, or X3 or intelligent, so on, Xn intelligent. So shorthand, how to we can write? There exist boys of X or intelligent of X. It will read as there are some X where X is a boy who is intelligent. So in diagonal representation, we have to show the like this X1, X2, X4 and so on Xn. These are the boys. We have to write the like this manner. Next, inferences in FOL. So in FOL, there are some inferences. Inference means deriving new facts. In that, some methods is there. Mode exponents, resolution, unification. Next, applications of FOL. FOL means first order logic. What are the applications? Expert systems, natural language processing, robotics, database students, knowledge representation. So many applications is available in FOL. So I wrote some points only. So expert systems is nothing but it is a machine understandable language. Natural language processing also machine understandable language. Robotics nothing but in robotics like examples Siri, Google, like that. Database systems in database systems, how to use this application by using the queries. Knowledge representations, the facts and relations are represented like a structured manner. Next, limitations. Complex for large systems. So it is very complex for some small systems. It is very good, but in large systems, the means complex for large systems. It is more complex. Requires more computation. Difficult knowledge engineering. Next, comparison. Proportional logic versus first order logic. Propositionals, simple facts only. FOL means what is the comparison between proportional logic and FOL? Proportional logic is simple facts only. So in simple facts means and or only. Whereas in FOL, objects plus relations plus quantifiers. Here we have to use the 3 statements in one single sentence. So final conclusion, FOL is an important AI concept, helps machines representation and reason about knowledge, widely used intelligent systems. So thank you.